Hey there, Math Hoppers. In this video lesson, we are going to tackle composition functions. So composition functions, when we use composition functions, it's another way of combining two functions, but we're not adding, subtracting, multiplying, or dividing them this time. What we're doing, we're actually creating a new function by using one function to evaluate another function. Normally we would use, or before now, we use numerical values to evaluate functions. Say f of 2, we would put 2 into the function. Now we are literally evaluating a function using another function as the input. Okay, the symbolism looks strange. It's like if you missed the day of class when they went over this, you come in and you would probably think, how long have I been gone? But it's not too bad. So it has two forms. This FOG with parentheses x and this f with parentheses g of x. This is my favorite. I actually can't stand this one, but either way they read f of g of x or f of g of x. This one is much clearer, and I will explain why in a little bit. Remember, these could also be g of f of x, depending on which function is the input, and we'll get into that. And of course, these could be any other letters, but you know I am a creature of habit, and I always use f of x and g of x. All right, so I said f of g of x is my favorite form because it really illustrates how composition functions work. Given two functions, f of x and g of x, the function g of x is the input for f of x, and it looks like it's the input. It's right there where you would normally see something like f of 2, there's g of x in there. All right, let's look at two functions and get to the bottom of this. So if we look at f of x equals x squared minus 2x plus 3 and g of x equals 2x, let's say we were asked to evaluate f of negative 3. Well, that would be easy. We would simply take negative 3 and plug it in for each instance of x in the f function. Why the f function? Because it said f of negative 3. So if we do that, it looks like this. F of negative 3 is the quantity negative 3 squared, which is 9, minus 2 times negative 3 plus 3. Putting it all together, we get f of negative 3 equals 9 plus 6 plus 3, or 18. All right, let's try g. Let's do g of 16. If we were asked to do or evaluate g of 16, we would simply plug in 16 for each instance of x in the g function. And there is only one. So we would say g of 16 is 2 times 16, or 32. And we would be done. So the problem comes in when we start putting functions in instead of numbers. But really the process is the same. To evaluate f of g of x, we simply plug the entire g of x function in to the f of x function for each instance of x. Okay? Think of this g of x function as the 2 or the negative 3 we just put in. So f of g of x, you could really say, well, what's g of x? G of x is 2x. So we're finding f of 2x. So instead of f of negative 3, we're finding f of 2x. It's a little more involved, but it's not terrible. So f of 2x is the quantity 2x squared minus 2 times 2x plus 3. So then we get 4x squared minus 4x plus 3. Now, we haven't talked about domains yet. Since there were no limitations on the domain of f of x or g of x, right? All real numbers here, you can put anything in for x. All real numbers here. Then the domain on the composition function is still all real numbers. All right, let's try g of f of x. So we're going to evaluate g of f of x using the same two functions we just used. To evaluate g of f of x, we simply plug the entire f of x function in for each instance of x in the g function. All right, so let's rewrite it. G of f of x is really g of, well, whatever f of x is. This x squared minus 2x plus 3. So g of x squared minus 2x plus 3. In the g function, everywhere I see an x, I'm going to replace it with that. And I'm going to put it in parentheses because it's more than one term. So let's do that. G of x squared minus 2x plus 3 is equal to 2 times the quantity x squared minus 2x plus 3. Don't forget to distribute. Distribute the 2 to everything in the parentheses. And we get g of f of x is equal to 2x minus 4x plus 6. Once again, there were no limitations on the domains, So the domain for the composition f of g of x is all real numbers. All right, now we'll look at some that are a little uglier because they have some domain limitations. Let's look at f of x, 1 over x plus 2. What's the domain limitation? Well, we know we can't divide by 0. X plus 2 is in the denominator, so we can't have x plus 2 equal 0. So x can't be negative 2. G of x has no limitation. Great, it's all real numbers. And we are going to evaluate f of g of x, where g of x is our input function. To evaluate f of g of x, we need to determine the domain of the input. We need to know what am I putting into this function and what limitations does it have. All right, well, the domain of x squared minus 4, we already said, is all real numbers. So we're good there. We don't have a domain limitation on our input. We will, however, on the composition. So now let's evaluate f of g of x. Now, I will caution you, some textbooks will tell you you must determine the domain of f of x at this point, and we really already did, but you don't have to. We will get the same result if we first find the domain of the inside function and then the composition function. So let's do f of g of x is f of x squared minus 4. So it's going to be 1 divided by, instead of x plus 2, it's x squared minus 4 plus 2. So we just combine like terms here, right? Negative 4 plus 2 is negative 2. So we get 1 over x squared minus 2. Okay, remember, x squared minus 2 is not allowed to equal 0. So even though I have f of g of x, I have a domain limitation. And what do I have as my domain limitation? Since x squared minus 2 can't equal 0, we solve for 0. What makes it 0? Positive and negative square root of 2. So that's our domain limitation. I would prefer to write my domain limitation like this. This indicates all real numbers except positive and negative rad 2. But we are going to write it in interval notation as well. So f of g of x is equal to 1 over x squared minus 2 with a domain from negative infinity to negative rad 2 and negative rad 2 to rad 2, not inclusive, and rad 2 to infinity, not inclusive. All right, let's try another one. Let's go the other way. Let's do g of f of x, and let's use two different functions. So f of x is the square root of x minus 5. So there's a domain limitation here. We have to have positive numbers or 0. And g of x is 3x squared plus 1. Okay, so this is a quadratic, all real numbers, no domain limitations, not too bad. To evaluate g of f of x, we need to determine the domain of the input. If we're going to put f of x into this function, we need to know what f of x can be. So the domain of f of x is x must be greater than or equal to 5, right? Because 5 minus 5 is 0, so it can be 5, and then it has to be everything greater than that. All right, and let's put this in another set of words. F of x can only be evaluated for numbers greater than or equal to 5. So we had to know that before we could put it into another function. Then each of those f of x values must be squared, multiplied by 3, and then added to 1. So the domain of the composition function is x must be greater than or equal to 5. All right, now let's evaluate g of f of x. So g of f of x is g of the square root of x minus 5. So we're going to take the g function and pop in the square root of x minus 5 for the one and only value of x. All right, plugging that in, it looks scarier than it is. Remember that squaring and square rooting are opposite operations. So when we square this, we simply are left with x minus 5. So we get 3 times the quantity x minus 5 plus 1. Let's distribute and clean that up. We get 3x minus 15 plus 1. And then we get 3x minus 14. This is our composition function. It looks like the domain should be all real numbers, but we know better. That's why we figure out the domain of the inside first, and we kind of make a mental note of it. We write it, put it to the side. So g of f of x is 3x minus 14 for all x values greater than or equal to 5. Okay, let's review the domain of composition functions, because I know the explanation in textbooks can be really scary. Long, wordy, horrible. All right, the rule for determining the domain of composition functions written in text, I just said it can be a bit long and wordy, but we're going to break it down. If we think about what we're doing, it is going to make more sense. Let's review the domain of taking the composition f of g of x. Since g of x is our input function or our inside function, we have to determine the domain of it before we can do anything. We have to know what values of g of x exist before we put it into another function. Then we evaluate our composition, f of g of x, and we determine the domain of that new function. The domain, since both functions are used in the new function, is going to be the union of both limitations on both functions' domains. All right, a real-world value, a real-world composition of functions. Let's do a shopping example, all right? Suppose you were shopping at a pool supply store in October in Minnesota. In Arizona, you might not get a sale because it's still hot. But in Minnesota in October, the store is offering 15% off everything in the store. You also have a $5 off coupon that you intend to use. So let's write the equations for both of these situations. 15% off everything, f of p, where p is the price of any good, is going to be p, the actual price, minus 15% of p, or 0.15p. So f of p is 0.85p. It's 85% of the original price is what you're paying. Cost with coupon is just p minus 5. All right, let's compose it both ways. G of f of p, so that's g of 0.85p. It looks like this, 0.85p minus 5. This is how they should do it. This is if the cashier takes the 15% off everything and then applies the coupon. Now let's do f of g of p. Now we have 0.85 times the quantity p minus 5. Let's distribute the 0.85 and get 0.85p minus 4.25. So look what happens here. The cashier first takes the $5 off and then applies 15%. So the 15% is off of a lower amount. So you actually pay more for the items. You do not want her to first take the coupon and then the 15%. You want the percent first. You want to pay less. All right, this was, a pretty good lesson, but I know there's a lot to it. I know the symbolism makes it horrible. If you have any questions, you're going through your homework, you're doing a quiz after this module, and you just still don't get it, you should be subscribed to our YouTube channel, and you should send your homework problems to us when you get stuck. We will make you a custom video solution that will help you out. Until next time, Math Hoppers, take it easy.